deal with the next topic, the types of mathematical statements. So we have universal, existential, and conditional. What are the differences between these three? Now, when we say universal, it covers all or none at all. So, everything or not, all or nothing. Right? Existential, it says at least one, or the other keyword here is the word some. So as long as even one exists, that is what we're trying to prove with existential. For universal, all of it must apply. The property must apply to all. Existential, the property applies to at least one. Now, conditional, it follows the format if, then. So there is a precedent and there is an antecedent. So if this happens, then this should happen. That is the conditional statement. Alright, let's have an example. All men are mortal. What is the property we're talking about? Mortal. Who are we referring to? Men. Our quantifier? All. So it is a universal statement. It says here that all men are mortal. So this property applies to all men. Right? So that is a universal statement. An existential one. Okay. Some men are cops. What's the property we're talking about? That person should be a cop. Does it say that all men? No. It says some men, meaning there is at least one man who is a cop. So that is an existential statement. Conditional. If it rains, then the fields are wet. Did it rain? If yes, then the fields should be wet. The fields are wet. What is the reason? It rained. So, a precedent and an antecedent. This is an example of a conditional statement. Now, how about this one? Okay, the statement says the square of a real number is non-negative. So, is it a universal statement, an existential statement, or a conditional one? In this case, it is a universal statement. Why? It did not specify which real number. Basta, sinabi lang doon, it is a real number. So the square of a real number, the square of any real number, or the square of every real number is non-negative. Our property here is non-negative. and then this is the key. So it is a universal statement. How about this one? There is an even prime number. If we're going to go to its semantics, the term there is already denotes that it is an existential statement because you are trying to say you're trying to prove the existence of one, or you're trying to claim the existence of at least one. So there is an even prime number is an existential statement because of this. Right. So in this topic, you just simply refer to the keywords. Once you see all, if you see at least, and if you see the format if then, you would automatically know if it's universal, existential, or conditional. Right? So that's right. Person is a priest, then that person is me. That's a man. The person is a priest, and that person is a male, or that person is a man, is again an example of a conditional statement. Why? What is our condition? That person must be a priest. If that statement is true, then our conclusion, that person is a male. Take note, I said priest. There is a separate term for females, which is priestess. So do not question the validity of this statement. Okay, so we have universal conditional statements. When you say universal conditional, it asserts that the if-then is true for all. Okay? So yun yung condition natin. Now, we'll have this example. All non-zero real numbers have positive squares. Now, we cannot see or we cannot find an if-then part, but we can convert this in such a way, or we can transform it in such a way that we are going to use the words if-then. So this is also the same as for all non-zero real numbers, hence the universal part. This is the universal part. What about the conditional part? All non-zero real numbers have positive squares. For all non-zero real number, if a real number is non-zero, then it has a positive square. There we go. So it's a combination of a universal statement and a conditional statement. So it asserts that the condition is true for all. So the if and then is true for all the variables involved. Now, universal existential. When we talk about universal existential, the key here is to see which comes first. Right? So in this case, let's compare this. Existential, universal, universal extension. Existential. We started here with the term every. We started here with the term there is. Notice the pattern. You start with claiming that it is true for all, and that something is true for all. In this case, right, so something is true for all. Now, what is that something here? That something is the lid. What is the all? The pot. So, every pot, universal, has a lid. This is the condition, or this is the property that exists for all. Okay? So for a clearer expression, for every part P, there exists a leaf L such that L is leaf for P. This is the more extravagant or more wordy version of this statement, but it is a clearer version on why it is a universal existential statement. So it starts with for every part, and then we are assuming the existence of something. So we are assuming the existence of a lid such that there exists a lid for every part P in a universal existential. Existential universal. There is a positive integer, so we start with a claim of the existence of something, but it must apply to all. And in here, what is that something? There is a positive integer, so that is our existential part. What is our universal part? This one. Less than or equal to all positive. So we started with there is and then followed by all. Universal existential, we started with all followed by there is. That's all you need to really know about these two. Now, basically these are just the semantics of mathematics. They are being used when we talk about theories, when we talk about theorems, properties, and this is how we write it in mathematics. It's quite wordy, but it is very definite, unlike when you use the common English language. So that's it. That's basically it, just to understand the theorems and properties. Now, you will not really encounter them in your day-to-day lives, as we prefer to use these types of languages, but for those majoring or those taking courses allied to mathematics, this would be very crucial in your future studies. For those not taking allied courses in mathematics, it's just for fun. Right? So that's the end of the video.